Hey, welcome back to the Computer Hardware and OS Essentials lecture series. I created these custom lectures based on A+ certification program but with few enhancements to improve your IT technical skills and knowledge. So if you haven't seen my previous videos, I will post a link in the description for the playlist, and I recommend that you watch those videos so that you have a better understanding about computer hardware. This will be our 7th lecture, in which I will cover power systems. The primary objective of this lecture is to learn about cooling methods that draw away heat produced by electronic components, the characteristics and types of power supply units, also known as PSUs, wattage capacity, how you can calculate it, and certain ratings associated with PSUs, basic overview of the differences in your desktop PC, laptop PC, and server power systems, and basic overview of power systems protection. How does cooling related to power? All electrical and electronic components produce heat. Heat is a byproduct as power being drawn to run those components. Why this happen? Because as electrons flow through those electronic components, it generates heat. Typically, high-powered computers and servers produce more heat compared to low-end computers. For example, the enterprise servers and gaming PCs produce a lot of heat. And we don't like those heats because that can also damage the components as well as can reduce the performance of those devices. Therefore, various cooling systems must be implemented to draw that heat away from those components. The power, heat, cooling, and performance therefore are related to each other one way or the other. So as more powerful your computer or components get, more likely to produce more heat, and having a better, properly built cooling system will help to draw away that heat. And therefore, the power, heat, cooling, and performance are related to each other. Cooling methods and devices. If the processor, motherboard, memory modules, expansion cards such as video cards, WLAN cards, etc., and other components overheat, that may result in system performance being significantly reduced or hampered because of that heat. This is known as thermal throttling. So the system performance gets significantly reduced as a result of the increase in heat. Or this will also result in systems that become very unstable, and eventually the components could fail or get damaged. So the heat is a really bad thing. So, it could result in reduction in performance as well as it could also damage your device. Devices used to cool a system include CPU and case fans, coolers, heat sinks, liquid cooling systems. General rules to cool the inside of a computer case include keeping the case closed, cleaning the inside of the computer or the server, and place the computer server at an appropriate place, etc., etc. So on the right hand side, you see my server stack in my basement. And you have all the network components at the top, and I have the server components at the bottom. And the reason why I have an open rack as opposed to a closed cabinet, because this is the best cooling option that I have in my house. So this would produce the best option for me to keep these servers running and cool. Processor coolers, fans, and heat sinks. Computer systems use a cooling assembly designed for a specific processor to keep temperatures below the processor maximum temperature. Good processor coolers maintain a temperature of typically 90 to 110 degrees Fahrenheit or 32 degrees to 43 degrees Celsius. Cooler sits on top of the processor. It consists of a fan and a heat sink or multiple heat sinks. Heat sinks uses fins that draws heat away from the processor. So the heat sinks are almost always metal, and metal is a really good heat conductor, and those metals have fins because those fins increase the surface area which the heat can be drawn away from the processor. The fan blows down the heat away from that CPU unit, and is made out, the heat sink itself is typically, as I mentioned, is made out of aluminum, copper, or combination of both, and usually, as like I said, is a metal because metals are very conductive of heat and very good components to use, a material to use for building heat sinks. Typically and almost always, these heat sinks and coolers are bracketed to the motherboard using a wire or plastic clip, and thermal compound is placed between the bottom of the cooler, heat sink, and the top of the processor. And typically those fans get powered with a 4-pin fan header on the motherboard, but specialized heat sinks may have a different types of fan headers. However, that's what we typically use, the 4-pin fan header. CPU coolers mount differently depending on Intel or AMD processor type you use. So make sure to use the correct bracket and assembly components. So even if you have an Intel processor, depending on whether it's a server processor or the desktop processor, it may have different assemblage on how you're gonna bracket it into place, the cooling system. Thermal paste, also known as thermal compound, must be applied to the base of the CPU heatsink. Some of the CPU packaging, especially consumer grade packaging, as well as sometimes server packaging, will come with the thermal paste already applied to the bottom of your heatsink, and sometimes they don't. So you have to actually apply it with a separate thermal paste compound. And the thermal paste would improve the heat transfer between the CPU and the heatsink by eliminating any air gaps. Some thermal paste are conductive and some other thermal paste are non-conductive. So if you are using conductive thermal paste, be careful about the thermal paste being spilled out from the CPU or the component that you're applying that thermal paste to. So if it is non-conductive, if it spills over onto your motherboard, it's not a big deal because probably not going to damage anything. But if it is a conductive thermal paste, it may cause issues where electrical shortages on your motherboard that will result in frying of certain components. So be careful with conductive thermal paste if you are using on your devices. Used on other components as well, such as GPU chipsets, Node bridge chips, built-in RAM heat sinks, etc., etc. But typically, as an end user, you would not be servicing those things unless you have a, like for example, really old server and you would like to replace the thermal paste on those items, such as the Node bridge, the GPU chipset, etc., etc. But however, typically the end user would not be messing with the thermal paste or thermal components associated with GPU's chipset or Node bridge, for example. The debate around how much of thermal paste should apply continues, and I would recommend that you go and watch the Gamers Nexus videos because they have done a couple of videos on thermal paste and how much thermal paste is needed. But however, the debate is going around like, how much is too much and how much is too little. What I would recommend is, as long as you apply thermal paste without leaking into the motherboard, that would be the best amount of thermal paste. And based on your processor, how much you need to apply may varies, because for example, AMD Ryzen processors, I believe, are a little bit of bigger footprint compared to the Intel i9s. So the amount of thermal paste may differ on the footprint of the CPU as well. So the debate around how much thermal paste is too much, how much thermal paste is too little, is continue, and it doesn't really matter as long as you apply enough thermal paste. And if you see any issues with your thermal paste, you can always reapply them. So a typical cooling CPU fan connection, as I mentioned, is either it's typically a 3-pin CPU fan cord, and typically get plugged into a fan header on the motherboard. And this is what it look like. A cooler fan gets power from a 4-pin PWM header on the motherboard, but the fan, the connection itself would be just a 3-pin connection, and it would go directly onto the motherboard. The reason why we do this is because this way your motherboard can control the fan speeds and how the fan gonna operate, because we are directly getting the power across the motherboard as opposed to directly connecting to the power supply unit. So remember, when you're plugging in items such as the SSDs, we give power directly from the PSU, the power supply unit. But when it comes to the point cooling of CPU, we typically get the the power across the motherboard, so that the motherboard have some control over the power being supplied to that fan. Case fans, other fans, and heat sinks. To prevent overheating, you can also install additional fans on your case. Case fans help draw air out of the case to prevent overheating. Most cases have one or more positions on the case to hold a fan. Large fans tend to perform better compared to smaller fans when it comes to the point drawing heat away from your components. Other fans includes some graphic video cards comes with multiple fans built into it. For example, a typical graphic card will have 3 fans associated with it. Fan cards can also be mounted next to graphic cards. So basically what happens is you insert a graphic card and you enter another card with the fans on it. But be sure to select a fan card that fits the expansion slot you plan to use, because if you use a fan card, if you purchase a fan card, but however it doesn't fit right next to the right next to the your GPU, it's going to be useless. Like, it's not going to be very useful in your configuration. You won't be able to install that fan card. Another thing I want to point out, fan cards are not very popular right now, so it's not something that typically in use in 2022, but it is still available. You can buy it. It's basically a card with bunch of fans on it. It goes into your PCIe or PCI slot, and it's just gonna blow air away or towards your graphic card. A RAM cooler clips over a DIMM memory modules and may be powered by a SATA 4-pin SATA power connector or 4-pin Molex power connector. And what it's going to do, it will provide additional cooling to your RAM modules for high performance computers such as gaming PCs. So here is on the left hand side 2 types of RAM cooling. One is the clip-on RAM cooling type that clip onto multiple RAM modules, and it will draw heat away using 2 tiny small fans. And the other type is a individual RAM module coolers. This one doesn't have a fan, so this is a passive cooler as opposed to an active cooler. These type of coolers basically clip onto your RAM modules, and then it will provide additional cooling surface by providing these fin type heat sinks that are connected directly to your RAM chipsets using these heat pipes. So you'll have these copper heat pipes that will draw power heat away towards these these heat sinks. But however, these are passive coolers, so it doesn't have this type of active fans that drawing the heat away from it, but still provide a better performance for your RAM compared to not having this at all. On the right hand side, you see a typical gaming type of GPU or high-end GPU that has 3 fans, and you can see the heat sinks underneath it. So these 3 fans are drawing the heat away from those heat sinks that are attached to the components of that GPU. Auxiliary fans airflow. So when you are installing auxiliary fans onto your desktop PC or even to your servers, you have to consider how the airflow works. Like on the left hand side, you see two correct and two incorrect way of putting fans to the same case. So in here we have two fan configuration. This is not really the same case, it's kind of different cases too. So in the two fan configurations, we have that air being blown in from the front and being pushed out from the back. And the cool air, the initial air intake will go across the motherboard and pick up some heat and go across the power supply source as well, and then get pushed out from the back. And in this configuration, we have two fans that are used to draw the air out, but there are no fans that being used to actively draw in the air in. Instead, we will have vents at the front without the fan installation. By having these two fans, it's going to create a negative pressure. So even though these two fans are pushing the air out or pulling the air out, the air will be drawn in without a fan in passive means because of this negative air pressure being created here. And that would still result in the cool air being drawn into the case and the hot air being blown out of the case, even though the case only have blowout fans, no intake fans installed in this configuration. Here's an example of incorrect airflows. So we have a fan that have an intake of air, but that is being directly pushed across a power source, which produce a lot of heat. Remember, PSUs, the power supply unit, produce a lot of heat because of the component containing within them. And if you blow air across the power source into the case, that's going to produce a lot of heat inside the case. And also the fan is installed incorrectly at the front. As a result, oh no, in this case, no, the fan is not incorrectly installed. The fan is still drawing the air into the case, the cooler air, but because this fan is incorrectly installed at the top, it's just not gonna work, because the heat is produced in this power supply gonna get trapped inside the case, and the heat is not drawn out because the front case fan also drawn in the air. So you have two fans drawn in the air. As a result, there is no way for the air to circulate, so air gonna get trapped. Here's another example where you have two fans right next to each other, but one of those fans is an intake configuration, the other fan is installed in the exhaust configuration. Because they are so close to each other, this happens a lot. I've seen with armatures who are building computers, they sometimes put intake and exhaust fans so close to each other that the one fan cancel out the other without the air being circulated across the motherboard and other components. So as a result, even though this does cool your inside of the case, it doesn't do an effective job. So it basically create an airflow that is basically considered as a short circuit airflow. So no airflow in the lower part of the case going to happen in this configuration. So keep in mind, the different cases have different locations for fan installations. Some cases also have fans installation capability of at the bottom of the case. You need to take into consideration and use some common scientific sense, scientific knowledge on airflow to determine the best possible scenario for fan configuration for use case situation. So be careful how you install your fans, and just follow maybe manufacturer guidelines. Sometimes it comes with manufacturer guidelines, but it all depending on your case and where you can mount your fans. On the right hand side, here's another example of a good arrangement of proper airflow compared to a poor arrangement on the right hand side. And it shows in here we have an intake fan or intake basically front vent, and it draws the air across, and the heat is being dissipated by exhaust fans on the back of the case. In the poor arrangement on this example, what happened is we have side vents, and we have a rear of the fan is rear of the case is here, and we have a power supply unit right here with the air being drawn, and the front of the case is here. So there are no vents at the front of the case. As a result, the drive base and the airflow on this side is pretty much non-existent, and there's very little air being drawn into the case, and not enough air is being circulated inside the case as a result. Again, I'm going to mention this key important thing. Depending on your PC case, the configurations can greatly differ from one case to another. So I can give you a very specific configuration that will always work for everything. When it's come to the point servers, I will recommend that you go with the server manufacturer's fans, and if you are replacing those with third-party fans that are maybe better performing, make sure that it fits into those server manufacturers configurations and do a better job than what comes in the box. Because typically with servers, we do not replace the cooling fans comes directly from the manufacturer, because they do a better job than anybody else can do. So that's why. And again, servers don't typically use liquid cooling or any other custom configuration. So I would just stick with whatever comes from the manufacturer when it's come to point servers. So my desktop computer, I just want to make a quick comment. I have vent at the top of the case. I have vent at the bottom of the case. I have vent at the front, and I have vents on the side. So I have utilized all of those vents effectively to make sure that I have a better airflow in my case. So I have very large 2 fans at the front right here, and I have mounted my liquid cooling fans that we're going to draw air out at the top right here, because typically warm air, what happened to warm air? Warm air rises, right? So instead of putting on the bottom of the case, I put the warm air heat out at the top of the case. I have 2 fans on the back drawing the air out, and I have no fans on the bottom of the case. I block them out because I don't want the heat circulation to mix them up. So that's the way I configure it. But again, depending on your case, you need to make sure you install the auxiliary fans accordingly, so that you will get the best performance out of your cooling system. Liquid cooling systems. Liquid cooling systems, sometimes known as water cooling systems. They are used by hobbyists attempting to overclock a processor in a gaming computer, but also gamers and other high-end computer users, such as engineers who use AutoCAD and other specialized CAD programs and specialized program that require specialized cooling in order to get the best out of the GPU and the processor. 2 types of liquid cooling systems widely used today includes the closed loop system, also known as AIOs, all-in-one units, and the other option is called the open loop systems. Compact closed loop systems often used in other desktop computers that may run applications requiring high usage of CPU or RAM. So it doesn't necessarily have to be gaming machines, even though gamers tend to be the people who use liquid cooling the most. As I mentioned, the engineers and other research scientists may also use liquid cooling on their desktop computers. In terms of performance, liquid cooling systems are almost always better than most of the air cooling systems in terms of drawing out the heat. So if you use the proper liquid cooling systems for your components, as opposed to using a proper air cooling systems for your components, the liquid cooling systems will almost always perform better. However, there is no significant difference in performance between closed and open loop liquid cooling systems. There have been many tests done by many other YouTubers as well as researchers and scientists, and they haven't found a huge significant difference in performance between the closed loop liquid cooling versus the open loop systems. Closed loop systems are, however, known for lower noise. So if you are using liquid cooling in your home and you would like to keep that desktop computer right next to your bed and you want to have it running even overnight, for example, I would recommend going with the AIOs as opposed to open loop system, because they tend to generate a little bit of more noise. It's not a big deal, but I should mention that here because some people don't know about that. Typically the open loop systems do produce a little bit of more noise. Components of an open loop liquid cooling. So typically they are custom built either by the end user in case you or by the manufacturer. To build those type of open loop liquid cooling systems, you also need specialized tools to like crimp the tubes or heat the tube up and bend it in a way the way you like. So for example, you can even get plastic tubes that are really hard plastic that you can bend, as well as you can use all glass. You can bend the glass tubes the way that you like. So you would need specialized tools to put them together. More expensive compared to that of the closed loop liquid cooling systems, as a result of these kind of specialized tools needed to do it, as well as the time that it gonna take to put them together gonna be much longer, as opposed to a closed loop system where you can basically install it within a few minutes. And the flexibility of cooling CPU, GPU, motherboard, VRAM, RAM, etc. increases significantly with open loop liquid cooling systems compared to closed ones. Reason for being, you can buy certain blocks that will go over those type of components, and you can build it any way you like, right? It's very flexible. Because it's open loop liquid cooling, you can build it the way you want it. Like if you want GPU, CPU, motherboard, VRAM, everything cool liquid using liquid cooling, you can do that. You can buy those blocks, you can interconnect them, and you can make your own configuration. So like for example, 10 people will have 10 different type of open loop liquid cooling, because each of these people can configure their cooling according to their needs, right? So you can decide if you just want to cool the CPU, you can do that. You want to do CPU and GPU liquid cooling, you can do that. You want to do all the items such as RAM, GPU, CPU, VRAM, etc. You can do all of that as well. So because of that, because you are building it, because it is custom built either by you or the manufacturer, there is flexibility in what component can be cooled using the open loop liquid cooling. And open loop liquid cooling contains these primary components. They include the CPU blocks, GPU block, the fittings associated with those blocks, the tubing, reservoir or pump, which should have a fill port where you can fill your liquid in there. Compatible case, so you need to have a compatible case that can handle those type of liquid cooling components, and the coolant you're going to use. So even though some people use the term water cooling, almost all liquid cooling systems in modern day use a coolant. This being because you don't want algae or other component, algae or other microorganism building up in your PC. So that's why you don't want to build an ecosystem inside your liquid cooling loops. So you use a specialized coolant so that are inert. I won't produce anything like that, any unwanted results. Additional components can be added as a result of these kind of custom liquid cooling systems. That includes the monoblocks, the RAM block, the flow fittings, specialized flow fittings. You can have specialized drain and fill fittings as well. That will give you a more flexibility in this type of cooling system. So here's an example of two examples of liquid cooling that somebody built. In this example, you can see these tubes are built, custom built for this configuration, and you can see a block, a liquid cooling block associated with the graphic card as well right here. in right hand side you can see the same things too. This is a liquid cooling block specifically for the graphic card. And as I mentioned, this is more labor intensive and more costly, because even these two graphic cards, whoever built this either have to buy this specialized graphic card more expensive with the liquid cooling block already attached to it, or they have to remove the fans and the coolers out of the graphic card and then reinstall or install this new liquid cooling block on top of their graphic card. So it is more time consuming and more work. In this example, they have used the blue colored plastic tubing, and they decided to create this spiral shape and etc., and does not have a separate reservoir, because the reservoir is basically whatever the liquid in these tubes and those blocks inside those blocks, that is basically the liquid. So that's the total amount of volume of liquid cooler in that system. In the right hand side system, I believe these are glass tubes that they use. They could have used plastic tubes as well, like transparent plastic tubes, and they have a separate reservoir with liquid cooling, so liquid cooler. So in here there is a lot of liquid cooler contained within this particular device, which is basically a way to increase the amount of the volume in which the cooler volume of cooler or cooling liquid contained in this open loop liquid cooling system. So right here it is still an open loop liquid cooling system, because these blocks do contain that liquid, and you have to custom build it, but it doesn't have a reservoir. But in here we have a reservoir increasing the volume of that liquid cooling. Again, these are more complex, typically installed by enthusiasts and gamers, and certainly not being installed in enterprise or small business environment servers. We never use liquid cooling. However, maybe used in a specialized servers that use for research purposes, because it requires that kind of a cooling mechanism. Components of a closed loop liquid cooling. So often these closed loop liquid cooling systems are known as all-in-ones, also known as AIOs, because they all come in a one single package. So this one package contains a water block or pump combination, radiator and tubing. And sometimes you could get two water block combinations as well for your memory and other components. But however, typically AIOs only have support for CPUs. In other words, it's only going to cool your Intel or AMD processor. But some manufacturers do offer the RAM, GPU and other component cooling blocks as well. Like in this example, there is a closed loop AIO with a RAM and the CPU cooling blocks already included in there. And these are much easier to install. As you see on the right hand side, you basically have a block for your component. So in this case, it's just a CPU, and you're going to attach that to your AMD or Intel bracket, and then you have the cooler. You can mount it according to the space and the configuration available on your PC. Like in here, they decided to mount it at the front, so they're gonna exhaust the heat out of here. So they take the heat away from here and then gonna exhaust it, and they're gonna have a small motor in here that's gonna pump this liquid back and forth between these fins right here, in the cooler, and the CPU block, the liquid cooling block right here. On my computer, my desktop computer, I have mounted at the top right here, and then I have mounted very large fans at the front for the intake, and then I have mounted this liquid cooling thing at the top. So again, there are debates on what is the best placement for a liquid cooling or AIO block mechanism. There are debates on the internet on whether it should be mounted this way, mounted top, or mounted on the bottom of the case when it is possible to do so. It's debates going on. As long as it works for you and your temperature is being properly controlled, just install it the best way possible according to manufacturer's guideline. That's my advice for you as IT professionals and technicians. Don't worry too much about enthusiast details associated with that. So what's really important here is all-in-one, also known as AIO, liquid cooling systems are easy to install, and it typically comes for cooling of your CPU only, but some specialized AIOs may have the CPU and other component support as well. Power supply unit, or PSU. So finally, a power supply is an essential component within a computer. Internal computer devices do not work without it. So without a power supply unit that properly conditioning power to certain voltages and wattage specifications, you won't be able to run internal components of a computer. The power supply converts AC current to a DC current, distributes the DC power to components throughout the computer, and provides cooling through the use of fan located inside the power supply. Every single power supply unit comes with a cooling fan, and that draws the heat away from the power supply unit and towards the outside of your case if you properly install it. The AC voltage a power supply accepts is normally either 100 to 120 volts or 200 to 240 volts. The reasons to replace a power supply unit on an already working computer could be that the power supply fail, a power supply in an existing system is not adequate. In other words, that you have a desktop PC and you decided to add a PCI expansion component, such as especially a graphic card, a high powered graphic card. Your power supply may not be able to handle it. In that case, you may have to replace your power supply with a higher wattage power supply. When building a new system, you can purchase a computer case with already power supply built into it, which we install onto the case. It doesn't mean that the power supply is not removable. It just the case comes in a combination of power supply and the case. And you can, if you decided to replace the power supply, you still can do it, but it may be a cheaper option. So by buying combination, or you can purchase a power supply separate from the case. So there are some gaming cases that do comes in built in, the already installed power supply that is more than enough for your needs. But typically when I'm custom building my PCs or even my servers, I buy the power supply separately, like the small business, just a general purpose servers. Enterprise servers already comes with power supplies that are proprietary to that particular model and the manufacturer, so I don't worry about them at all. But when I'm building a desktop type small business server, or when I'm building my own desktop PCs, I typically buy power supply separate from the case, because I calculate how much power I need and I buy a little bit more than what I need. And I can that way also make sure that I buy a good power supply, better rated power supply, and from a better company than just buying with the case. But there are some cases actually comes with really good power supply already installed, and you can look into that as well. Basic power supply features includes the form factor, which determines the power supply size and the shape. Especially when it's come to the point servers, you don't have a choice. But when it's come to the point desktop PCs, you have several form factors you can pick from. Wattage ratings, which is typically listed on the documentation as well as on the power supply unit itself. You can just read it from the case. Number and the type of connectors. Fans inside the power supply units, because sometimes there may be multiple fans. Dual voltage options. So most power supply units in 2022 that you can purchase in Canada at least can support both 115 and 230 volts, but that may not be the case in where you are. So you can look it up, and most power supply units nowadays, it does that automatically. But some power supply units, on the back of the power supply unit, there's a small switch where you can switch between the 115 volts and 230 volts. So look into the documentation for that information, depending on the type of power supply you purchase. And warranty and overall quality is also another consideration you should take into account. I've seen a lot of cheap Chinese knockoff power supplies being sold on eBay, so be careful about that, because your power supply unit is pretty much a dangerous item to get it on a second hand, because it can actually catch fire and cause power issues and could burn out your components. So be careful with the warranty and overall quality, especially if you're buying a Chinese knockoff power supply from eBay or something. Power supply form factors. So power supply comes in different shapes and sizes, as I mentioned before, and so do cases, right? So not all cases can support all power supplies, but some cases can support all power supplies. Today, power supply form factors are ATX, ATX 12 volts version 1, ATX 12 volts version 2, micro ATX, etc. So those are the modern day 2022 power supplies typically that we get in the market. The ATX power supply form factor allows a small amount of voltage to be provided to the motherboard. The ATX 12 volts version 2 standard has a 24-pin motherboard connector instead of a 20-pin version 1 connector, and have a SATA power connector. The micro ATX power supply form factor is a smaller version than a full-size ATX power supply to fit in smaller cases, so that you conserve some space. Laptop and server power supplies are typically proprietary. So depending on your laptop internal power supply components, you may or may not be able to replace those internal components, but the actual power supply for the laptop is actually located outside, which is your power brick, right? The brick that comes with that converts your AC power to DC is outside, so that can be replaced easily, but the internal components of the power supply is typically harder to replace. And when it's come to the point server power supply, they are proprietary power supply units. Those are basically like unique to, like for example, Dell servers, unique to HP servers, unique to IBM servers, etc. So each power supply unit associated with each server is unique to its manufacturer as well as the device model. So keep that in mind, right? Some power supply units comes with modular cables. So for example, in this picture, this power supply unit will comes with these modular units. So you don't actually need to use all of these cables. So in the old days, the power supply unit will have all the cables coming out and all these connectors are attached to those cables, right? But nowadays you can get these modular type power supply units where you only can use the cables that you need, and you can not use the cables that you don't need. As a result, your case will be more clean, and the cable management going to be much nicer, because if you don't need all of these cables to be used, you only use the ones you need. You are not going to have extra cables hanging around inside your cable box, right? So inside your PC case. So that's what that's one of the advantage of using a modular type of power supply unit. I would recommend in 2022, with the prices significantly going down with the modular power supply unit, that whenever possible you use a modular power supply unit for your custom PC configurations, because they are much easy to work with, and you can have a really nice cable management that you otherwise won't be able to get with the traditional power supply unit, where you have all the cables coming out and there's no way to disconnect any of those cables. Power supply unit rails. A power supply rail is a supply voltage that is provides power for electrical or electronic devices or components on a circuit board. So this is a common phrase or term used by IT professionals. Rails, power supply rails, so what basically a rail is, it's a common power supply circuit that can be used by multiple components. You can think it that way. Like for example, a rail of 3.3 volts will have a 3.3 volts going across that rail, and that any component that use that 3.3 volt can be connected to that rail. Power supply rails used for early desktop computers included 5 volts and direct current 12 volts current, and is like the modern day, most of the common rail is going to be 12 volts, but in the old days we also had the 5 volts rails. So for you, like as an IT technician, as an IT professional, what you need to know is the rail is basically a circuit. Like think of it as a circuit. So you have a 3 volt circuit, you have 5 volt circuit, or you have a 12 volt circuit. So these are called rails. So this is a rail for 3.3 volts, you have a rail for 5 volts, and you have a rail for 12 volts. Those are circuits which you can use to power up your components. So or if you have 12 volts components, you can put all 12 volt component in the 12 volt rail, and the 5 volt component will go in the 5 volt rail, etc, etc. So here's just a quick a table that explaining like SATA can support 3.3 volts rail, 5 volt rail, and 12 volt rail. And Molex have 5 volt rail and 12 volt rail. 24 pin P1 type will have the 3.3 volt rail, 5 volt rail, and the 12 volt rail. So the main this is what we typically use to connect power to the motherboard. So this is where the motherboard get the power, 24 pin P1 type connectors. So again, the reason why I mentioned the rails in this lecture is that it is a term that is used a lot in the industry, and as a new IT professional that you should know what it means. So that's why it is here. So remember, the rail is, you can look at as a circuit. So 3.3 volt circuit, 5 volt circuit, and 12 volt circuit. So therefore the 24 pin P1 have 3 rails associated with it. So rail is type of a circuit, power circuit, that you can connect components that can support that particular voltage. So that's how you look at the rails. So information on the voltage rails can be found on the side of the PSU or power supply unit, or in the documentation provided by your manufacturer. So in this example, the Cooler Master 650 watts 80 plus bronze power supply unit have rails for 3.3 volts, 5 volts, 12 volts, and plus 12 volts minus, and 5 volts SB. So we have all of these rails, and it will tell you what is the maximum power that each of these can provide. And in here, if we look at, I'm highlighting the 12 volts rail, and we know the DC output is 52 amp maximum, with the maximum power out of 624 watts. In that 12 volt rail can support, right here, 624 watts maximum, right here it shows there. So this is how you actually read those rails on a back or side of your power supply unit. On the right hand side, you see sometimes the documentation that comes with this type of power supply units. They will have the connector listed, the lead pin information, and the type of rails associated with that. In this example, for example, the P8 have a 12 volts positive rail on the yellow, and the 12 volts negative rail on the blue. And you know this because you're reading this information out of the manufacturer's booklets. So that's how you read the power supply unit rails and what that actually means. So if you look at the ATX power supply connectors, so those connectors include SATA connectors, Molex connectors, 20 to 24 pin main power connector, which is used to connect to your motherboard, and also the 8 to 4 pins connector, 6 to 8 pin 6 or 8 pin connectors, 6 pin PCIe connectors. So all of these are types of connectors that you might get from your power supply unit. Again, if you have a modular power supply unit, you will have these things in modular configuration. So you can plug it in one of these to your the power supply unit, and then the other end get plugged into whatever the component that needs to get plugged into, and you don't need to plug in all these cables on your modular devices. But if it is non-modular, you will have all of these things on your device. And keep in mind, these connectors oftentimes have pins. Like for example, this one has a pin right here and this one has a pin right here. So when you plug it in, make sure the pin get clicked in. And when you want to remove a power supply cable, make sure you press down hard on these pins, like hard enough, so that when you pull it out, you don't break anything on your motherboard or your components, because the pin is locked into the place, right? Make sure the pin get unlocked when you want to pull it out, and pin get locked in when you want to push it in and get the power, give the power to those components. One more thing I want to highlight before we move on to the next slide is that almost always, like all the time, these modules only go in one direction. So if you have to force one of these power blocks or power connector into your component, that means there's something wrong. You're doing it wrong. You shouldn't be able to plug this in the wrong direction, and you shouldn't be forcing these connectors onto your components. It should go in smoothly. You may have to apply a little bit of pressure to make sure that these pins, this clip get locked in, but you should not require, it should not require a lot of force to get these things connected. How to calculate wattage capacity? Determine wattage capacity. You need to consider all the components inside the case, or inside your in your configuration, right? Consider USB devices as well that get power from the port connected to the motherboard, and also any external devices that you may plug into your device, or such as USB 3.0 port that may draw a little bit power. I would also consider that a little bit, because that may play into come into play, but not so much. Internal components are way more important when calculating wattage capacity than external components, but you should also think about the external components as well, because there are motherboards that can supply a very high wattage to USB 3.0 external ports. In that case, you need to make sure that you have a power supply that can handle it. Points to keep in mind also includes the video cards that draw a lot of power out of all the other components. Compared to all the other components, video card can draw a lot of power. The power supply should be rated 30% higher than the expected needs. That's another thing that you should take into consideration. So after calculating all your wattage capacity needs for your particular configuration of your desktop computer, or even a server configuration, custom server configuration, you should always make sure that the power supply is rated at least 30% higher than the need. So, or more even. It is up to you to go more, but because it's going to be you're going to increase the cost associated as a result of going more, but at least minimum 30% higher than the expected need. Do not calculate down to last wattage unit and then buy a power supply exactly to fit that wattage need. Don't do that. Add additional 30% on top of that overhead. And you also need to consider what size of the power supply. Adapt the voltage requirements and add 30%, and that's how you're gonna calculate that size. So what that that is something that you should take into consideration when you are picking a power supply for your device. When you are calculating the wattage requirements for your configuration, here are some typical approximate wattages associated with different components that you can use as a guideline. Again, I'm going to highlight this. Please read your manufacturer's guidelines with respect to the power needs for each component when you are calculating wattage capacity, as opposed to just going with the typical guidelines like this. But if you don't have access to your manufacturer's material, or whatever the reason that you are configuring an older systems with newer components and you want to quickly gauge some wattage capacity, you can use a table like this. So typically, not always, but typically, motherboard, processor, memory, and keyboard and a mouse on a typical desktop home computer, a home desktop PC, is around 200 to 300 watts. 200 to 300 watt. A typical fan would be around 5 watts. Again, there are fans that take way more than 5 watts, and there are fans that take way less than 5 watts, but this is typical. A SATA hard drive is typically 15 to 30 watts. but the SSDs may be taking less power than that, so it depends on what type of hard drive, SATA hard drive you have. The Blu-rays, DVD, CD drives typically take 20 to 30 watts. The PCI video cards, that takes about 50 watts. Those are like PCI low-end video cards. Those are not high-end video cards, because high-end PCI E16X video cards can take up to 150 to 300 watts. The PCI network cards or other PCI basic network cards, such as the Wi-Fi cards or LAN cards or things like that, those could take up to 20 watts. And PCI E16X, other types of video cards, and not very high end, but in between video cards, could take about 100 watts, and the RAM modules typically take about 15 watts. And if you add additional cooling systems, as I mentioned in the previous slides, that's going to take up power as well. So if you decided to add a liquid cooling system, that may draw power to that needs power to circulate the liquid coolant across your system, that needs power to run its fans, and all of those needs to be taken into consideration when you are calculating wattage capacity to your particular use case scenario. So keep that in mind. This is just a rule of thumb, but this is not the golden rule, or this is not the rules that you should be using. The golden standard should be your manufacturer specification for each components, and look at the wattage requirement. So this will give you an overall picture of it, but not the golden rule. Keep that in mind. Power supply unit rating. So if you go to a website, or if you go to the market to go to the store to buy a power supply, it will come in this rating called 80+ ratings. So the 80+, which is trademarked as the 80+ with a PLUS plus with this term with these letters, is a voluntary certification program launched in 2004 by manufacturers. So it is not a it's not a proprietary one, and it is not a legal requirement in many countries. So many countries do not have a legal requirement for these type of ratings. For example, I don't believe, I'm in Canada, I don't believe even in Canada, where the Canadian government or provincial governments have any requirement for PC, power supply, you need to have these ratings. So it is a voluntary requirement, voluntary thing. And it is intended to promote energy efficient, power supply units. However, it may varies from manufacturer to manufacturer whether they provide these ratings or not. Certification is, basically based on a certain set of rules that these manufacturers follow, and that's rules will govern what kind of certification rating will be associated with their power supplies. So if you look at those ratings, we have 80+, we have 80+ bronze, 80+ silver, 80+ gold, 80+ platinum, and 80+ titanium. And on this table, it clearly defined how that is associated with the efficiency with respect to 115 volts, 230 volts internal redundant, and 230 volts European Union internal non-redundant. I'm not going to go over any more detail than that. You can pause this video here and check this in a table. This is directly copied from Wikipedia article on 80+. So if you want to go there and check it out, just Google on Wikipedia 80+ ratings power supply units, and you'll get to this page. For what you need to know is, for typical home use gaming PC or even a home use desktop PC for office use, or office end client PCs, 80+ is more than enough. However, if you keen on having a better power efficiency, you should go all the way to 80+ titanium. But remember, that will significantly increase the cost associated with your power supply unit. So the power supply unit that is rated for 80+ or 80+ bronze going to be much cheaper than a power supply rated for 80+ titanium. Again, in 2022, I don't see the need of going more than maybe 80 plus bronze for any home build PC, for any work purposes. For even gaming, high-end gaming PCs, I don't see the need for the 80 plus titanium. But if there is a sale in the market for 80 plus titanium power supply unit, maybe you should get it, because that will give you a better energy efficiency. So again, 80 plus and 80 plus bronze is more than enough for most desktop computers, but you may go for higher end if it is available to you, and if there's a sale or cheaper price, you should go for those ones, because they will give you a better power rating. One more thing I want to highlight when it's come to this 80 plus standard. This 80 plus standard does not directly relate this 80 plus standard do not get related to the how reliable the power supply is. A lot of people in the market, a lot of junior IT technicians as well as consumers believe that 80 plus titanium is more reliable power supply than 80 plus bronze or 80 plus power supply unit. That is not the case. You can go and buy an 80 plus power supply unit manufactured by a really good company that would have a very good reliability, as well as you can go and buy an 80 plus silver power supply rated power supply from some manufacturer who's done a poor job in quality control and have a high failure rate. So what this power supply unit rating is doing is it is rating the energy efficiency. It does not rate the reliability and manufacturing quality. So the 80 plus titanium has nothing to do with reliability and manufacturing quality. It has to do with power efficiency. So keep that in mind. I have an 80 plus power supply. It's not bronze, it's not silver, it's not gold, it's not platinum, it's not titanium. That is running on my HP and Dell servers in my house. And that has been running for years, actually almost a decade, one of them. And at the end of the day, because it's manufactured by Dell, it was manufactured by HP, they are well built power supply units. It doesn't matter, it doesn't have the titanium or platinum or gold rating, it is still well built. So keep that in mind. The power supply unit rating has to do with energy efficiency, and it has nothing to do with the manufacturing quality or reliability. And for a typical desktop computer or a business use computer, 80 plus is more than enough. You don't even need 80 plus bronze, but if you really want a little bit more out of your power supply energy efficiency, maybe go for 80 plus bronze, unless otherwise the other units are cheaper because due to a sale or something. So keep that in mind. Laptops and servers. Finally, I'm just going to give you a broad overview of laptops and server power supply. Primary power conditioning occurs outside the laptop via the charger or the brick. So for the laptops, it is possible to use a compatible universal power chargers when replacing your laptop power supply brick. So basically, this is what we have on laptop. It is an outside component, very easy to replace, very easy to service. There are certain little components associated with these power supplies for laptops inside the laptops, and they are typically never replaced by end user or even the manufacturers. If the manufacturer has to replace a component associated with the power supply for the laptop, they typically replace the entire motherboard because it's part of the motherboard typically. So the laptop primary power supply conditioning units are outside the laptop, and it is going to be a power brick like this, and you can replace it with compatible even universal chargers. You don't need to even get the one directly from the manufacturer. However, when you contrast that with servers use proprietary form factor power supply units. They are also easily replaceable because almost always all server power supply units are like these. So they are basically, you can pull it out by pressing a button like right here. You can press this latch and you can pull the power supply unit while the server is working. So remember, hot swappable power supply units are power supply unit that can be replaced while there is another power supply is powering the the components of your server, right? So in here, for example, if you just pull one of these and leave the other three in, or pull three of these and leave the last one in, you should be able to replace this power supply while the server is running 24/7. There won't be any downtime because these are built in a way that are hot swappable. However, that also means typically you cannot exchange a power supply unit between different manufacturers and models because these are specifically designed to work with that particular model of your server. For example, this is a Dell power supply unit and this is a different manufacturer. I won't be able to plug this thing in this server. And look at the pins on the back. These are built specifically for hot swapping, and these pins are specific to these type of Dell motherboards and the servers. So the server cases and the motherboards are specifically related to that server case, is built to take this hot swappable power supply unit, and you have to get it directly from the manufacturer so that it will actually fit in your server. Advantage of hot swappable, as I mentioned, with the servers is that you can pretty much replace this power supply unit without having any downtime, as long as you have at least one hot swappable power supply supplying power to all your server components. So that's what the big high level overview of laptop and server power supply units. Installation of power supply units. So for laptops and servers, there is nothing much to worry about, right? So for laptops, it is an external block. For servers, it is a modular hot swappable units, and they don't even have cables. See, you don't even have cables that are associated with desktop power supplies. These are just gonna fit into the pins inside the server board, and then the server board will have the cables going into respective components if there is a need for the power cables to go. Otherwise, the server board will provide the power using the electronic traces on the motherboard, right? So the server board will have these traces of electrical wire that already printed onto the motherboard, and that will be powering the component. So you don't even have cables to worry about when it's come to the point servers. Just hot swap and you are good to go. For laptops, just replace the external components and you're good to go. But when it's come to the point desktop computers, please follow the typical guidelines mentioned in my previous lectures. As I mentioned before, make sure you have anti-static strap and make sure you don't discharge any power to the motherboard components when you're replacing it, etc., etc. And make sure to use the correct power connector and correct voltage rail for right components. Typically, you cannot connect a wrong power cable onto a wrong component, but there are situations I've seen in the field where you can actually connect a wrong power cable to a wrong component, because if you jam it in hard enough, it will go in. So don't do that. So make sure you use the correct power connector to the correct voltage rail, or you might fry a component, or your component won't power on. It is next to impossible, like I mentioned, to connect a wrong connector on a modern PC components, unless you actually force to fit that power connector in the wrong place. So keep that in mind. If it doesn't go smoothly in, maybe it is the wrong connector that you are using. So when you are working with desktop computer power supply unit, don't force anything in. Just use the proper connector at the proper place. Power systems protection. So computers need a steady stream of AC that the power supply converts to the direct current, which then be used by your components. Sometimes the AC voltage is too high or too low, so therefore we need protection from those kind of situations so that you don't get your components fried out, right? So to do that, you can simply use a surge suppressor or like a surge protector. So instead of plugging your desktop or servers directly onto the wall, you can use a surge suppressor in between. Line conditioners, that's another type of component that you can use. UPS, which is uninterruptible power supply, that provide power during an outage and conditions the voltage when there is no outage. SPS, those are called standby power supply, that provides power during an outage but does not provide constant power. So there may be a short period of power outage. Where do you see SPS are being used? They are used sometimes in enterprise environment. So you will have a UPS and a SPS. The UPS will have more battery capacity compared to a UPS. Any switch over time less than 5 milliseconds in modern 2022 standard would be considered as good enough for most systems. So if the switch over time between the power going out and the UPS supplying that power to your device, 5 milliseconds or less is more than enough for most modern computer systems, including servers. And you can get UPS units, something like these, where basically a separate block that you can, a device that you can then plug into the power, as well as plugging into your devices where it's going to be supplying that power. Or the UPSs can come in a form factor where you can mount it onto a rack mountable system. So in here we have rack mountable servers, maybe on underneath here or at the above, and then you put the rack mountable UPS devices installed just like a rack mountable server or other rack mountable components, and this will save space and can make it easy to fit into a server closet. What really important here is that you pick the right protection, and you make sure that you safeguard your servers and computers and devices from power related issues, right? So that keep in mind. And one more thing is that the UPS devices that you can buy, the consumer grade as well as enterprise grade UPS devices, already have surge suppression and line conditioners and everything built into one single unit. So if you have a UPS unit like this or UPS unit like this, there is no need for surge suppressor or line conditioner. It is highly not recommended to plug a UPS unit onto a surge suppressor. So if you have a surge protection strip between your wall and your UPS, that is bad. UPS should be always plugged directly onto the wall outlet of your power. So if you have whatever, you directly plug the UPS directly onto your city or your building's power supply. You don't put a lines conditioners and surge suppressors in between, because that will cause your UPS to malfunction or prematurely go out of service. So keep that in mind. So UPSs should directly connect to the wall, because it already comes with the surge suppressor and line conditioner. And that would be the end of this lecture. Please thumbs up this video and subscribe to my channel. And until our next lecture, good luck and have a nice day.